last electrons are entered to the p orbital, hence it is known as what? p-block elements. From showing the negative values, it shows a positive value because it's already completed, having a stable electronic configuration. So argon is only the noble gases which is abundantly found in the air compared to other noble gases. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, today we are going to start with the Unit 7, the P-block elements with the revision classes. Let us understand what is all about the P-block element consists of. So we already know that in the modern periodic table that is discovered by the Henry Moseley, so towards the right side, okay, you can see that there is a blocks which has been started with the group 13 to group 18. Okay, so generally when we are studying, okay, we say that from group 13 to group 17 as only as P block, except this group 18 because group 18 is what? Noble gases. Correct? So group 18 is the noble gases or the inert gases which does not comes under the P blocks actually, but we say together as what? P block elements. In a periodic table, the P-block elements are placed in a group 13 to 18 having a general valence electronic configuration is Ns2 Np6. If you start with the group 13 to group 18 together when you are saying it is a P-block, it has a outermost electronic configuration of Ns2 Np6. Okay, this is the outermost electronic configuration where the p orbital last electrons are entered to the p orbital, hence it is known as what? P-block elements. The properties of the P-block elements are influenced by variations in atomic size, ionization energy, electron gain enthalpy, electronegativity and the first element of each group which shows the anomalous behavior. It is very important. Okay, anomalous behavior from the rest of the members of the same group. You can see that I have placed the P-block elements, the first members in all the groups, you know, like a boron, carbon, nitrogen, oxygen, fluorine, even helium. Okay, if you say with the group 18 also, all these first members, you know, it looks different from the other rest of the elements of the same group. Why it is different? What made these elements to become different? Everything, you know, along with their few periodic properties such as atomic size, ionization enthalpy, electron gain enthalpy and electronegativity, we are going to discuss in detail in this unit. Okay, so I have covered each and every topic in my concept class. Let us see what is important when we are doing the revision for this unit. So from this unit, we can expect maximum of 12 marks. There is a one question from the 1 mark and there is a one question in the 2 mark, that is a question number 9 and 27, and as we know that this is a unit which is belonging to the inorganic chemistry, so we can expect question number 27, 28 and 29 definitely will come from this unit, and remember these questions are mainly present in a part C. Next, so we are going to discuss with the 1 mark, 2 mark as well as with the 3 mark question. Let us see which are the important 1 mark question which has been repeatedly asked in the board exam. Among the noble gases, which one of the gas is most abundant in air? So as we all know that in the P-block elements group 18 also, which included when you are studying in together, but in general, you know, when we are talking in detail, we say that group 13 to group 17 as P-block when we are studying in detail. Okay, so argon is only the noble gases which is abundantly found in the air compared to other noble gases. Name the noble gases which is radioactive. Radon is the noble gases which are radioactive in nature. Remember, the 1 mark question from this unit, you know, definitely they are going to ask from the group 18 only. So from the group 18, we can expect one 1-mark question, or in the form of 3 marks, it will be split into 1 plus 1 plus 1. Okay. Give reason for the chemical inertness of noble gases. The reason for this is the outermost electron shell are completely filled so that they have a little tendency to gain or lose the electron. This is known as what? Chemical inertness. Okay. So, you will study the group 13, group 14, group 15, group 16 and group 17. All these elements, they shows the chemical inertness. So, what is the reason for this to become a chemically inert? Because the inner shells are completely filled. Since it is completely filled, it has become stable and hence they are become completely inert as we move down the group. So, what is passivity? Some metals like aluminium and chromium do not dissolve in concentrated nitric acid due to the formation of protective layer of the oxide on the surface of the metal. This is known as what? Passivity. So, if you take chromium metal, imagine this is your chromium metal. Okay. So, now you have added concentrated HNO3 for this. What will happen? We know that concentrated HNO3 will attacks on the surface of the metal. So, this metal which forms a protective layer, okay, above on its surface. As a result of this, when we add a concentrated H2SO4, this inner part does not get affected. This process of development of a protective layer on the surface of the metal, which we call it as what? Passivity. Okay. So, name the 16th group P block elements which has radioactive in nature. So, polonium, which is belonging to the oxygen family, which is nothing but a group 16, which is a radioactive in nature. Next, what is aqua regia? It is very, very important. Aqua regia, it is a mixture of concentrated HCl with a concentrated HNO3 in a 3:1 ratio. Remember, HCl will be taken in 3 ratio, whereas HNO3 will be taken in 1 ratio. Okay. Name the gases which have larger positive value of electron gain enthalpy. Noble gases have a larger positive value of electron gain enthalpy. Why? So, already we know that the last group element, that is the group 18 elements, are stable. Why it is stable? Because of the completely filled electronic configuration. Since they are very stable, we cannot easily add the electron to the group 18 elements because they are completely filled. They have a satisfied number of electrons. Suppose if I am forcefully adding an electron to the group 18, this shows the positive electron gain enthalpy. If you add the electron, we have to put more energy to pull the electron inside the such elements atom. Okay. So, that is why instead of showing the negative values, it shows a positive value because it's already completed, having a stable electronic configuration. Okay. Next, name the noble gases which does not show NS2-NP6 electronic configuration. So, helium is only the exceptional cases which is belonging to the noble gases which do not show NS2-NP6 because it do not have a much electron. Their atomic number is only 2. Okay. Which noble gases can diffuses through rubber and the glasses. So, helium is only the noble gases which can easily get diffuses. Give an example for oxo acids of chlorine. So, as I have discussed the many oxo acids in the P block elements in the group 16, group 18, group 15, group 14, group 13. Okay. So, since the halogens are belonging to the group 17, you must know that how differently each elements can form a oxo acids. So, for the chlorine, I have given one example, that is hypochlorous acid. The formula is H4Cl and it looks like this. This is the structure. Next, we will go with the 2-mark question. Mention any 3 reasons for the anomalous behavior of the nitrogen. So, instead of nitrogen, we can expect oxygen. Okay, we can expect boron. Okay, so like this, or fluorine. So we can expect the first members of the P block elements are usually shows anomalous behavior. Why it is like that? We have to write the reason for that. Only because of the smaller size, then high electronegativity and ionization enthalpy, and non-availability of d orbital. It is very, very important. In the first member of these elements, there will be no availability of a d orbital for the further hybridization, so that they shows the anomalous behavior. Next, mention any 3 reasons for the anomalous behavior of fluorine. This is also asked many times. Because of the smaller size, because of the high electronegativity, non-availability of a d orbital, and dissociation enthalpy in the molecular form, it is very, very least. Next, mention the anomalous properties of, it is anomalous property. The last we have learned the reason. Reason for the anomalous behavior and the properties of the anomalous behavior is different. Okay. So, nitrogen is gas, while others are, which is belonging to the nitrogen families, are usually solid at room temperature. Nitrogen is only a diatomic. We write the nitrogen as N2, not as N. Okay. While other element of the same groups are polyatomic. Nitrogen has a maximum valency of 4, but the other elements of this group will show a covalency which is more than 4 also. And nitrogen is less reactive compared with the other elements of the same block or with the same group. Okay. This is the properties of nitrogen to show its anomalous behavior. Next, how ozones are prepared. It is very, very important. So, how does ozone can be prepared? It is obtained by slow dry stream of oxygen is passed over the silent electrical discharge, and conversion of oxygen to ozone will take place. So, you are converting oxygen to ozone in presence of silent electrical discharge. Silent electrical discharge, which means that during this preparation of ozone, there will be no sparks which has been produced. Next, what happened when a chlorine is reacted with a dry salkid lime? Remember, dry salkid lime, which is nothing but your calcium hydroxide, and is known as what? Salkid lime. It is known as what? Salkid lime. When chlorine react with your salkid lime, what will happen? It forms CaOCl2 plus CaCl2 and H2O. The CaOCl2, which is nothing but bleaching powder. Bleaching powder. Okay, with the calcium chloride and H2O is formed. Next, we'll go with the most important preparation in the P block. Definitely from these 3 questions, you can get a 1 question. One is preparation of nitric acid by Ostwald method, preparation of sulfuric acid by contact process, then preparation of ammonia by Haber's process. Okay. First, I'll go with the give a balanced chemical equation with a condition for the manufacturing of nitric acid by Ostwald process. Okay. Here, you need to see the question properly, understand the question, what all the question consists of, whether sometime they'll ask you to write the condition, catalyst, and sometimes with the steps. Okay. Sometime with the diagram also. Okay. You must know that how to answer for that given question. The first step is in the preparation of ammonia by a Ostwald process. We have to take ammonia here, then we have to oxidized. Okay. So, we have to do the oxidation in presence of suitable catalyst. So, the mixture of ammonia is passed to the air over the platinum or rhodium gauge catalyst at a 700 to 900 Kelvin. Ammonia is formed. What does it form? So, ammonia, when it is passed to the oxidizing agent like an oxygen in presence of the platinum or a rhodium catalyst at a temperature around 500 and a 9 bar pressure, it forms a nitric oxide with the formation of water. Since the reaction is exothermic, lot of heats are liberated. That temperature is maintained by the catalyst. Next, step 2. oxidation of nitric oxide to nitrogen dioxide. So nitric oxide is further oxidized to get a nitrogen dioxide. It's the second step which we do the further oxidation. In the third step, formation of nitric acid will happen. That is obtained by dissolving this nitrogen dioxide with water. Okay, so when we dissolve it, it forms a nitric acid with the liberation of nitric oxide. Again, this nitric oxide will be reused for the entire cycle. And if you wanted to get a concentrated nitric acid, we have to go with the fourth step. That is, solution of HNO3 is concentrated by distillation until to get a constant boiling mixture. Constant boiling mixture is obtained and strength is nearly 68% by mass, and further concentration up to 98% can be obtained by dehydration with concentrated H2SO4. So this is your exceptional cases. Okay, that is step 4 is exceptional cases, but remember all the 3 steps. First one is oxidation of ammonia into nitric oxide. Second step is further oxidation of the nitric oxide to nitrogen dioxide. The third step is the formation of HNO3, that is nitric acid. Okay, all the first 3 steps you have to know, and the last step it's all about the concentration method, how to get the constant boiling mixture of a concentrated nitric acid. Next, write the structure of hypochlorous acid, chlorous acid and chloric acid. As I told you, the hypochlorous acid formula is HOCl. You can see that H we have oxygen as well as a chlorine. These are the oxo acids of chlorine actually, and the chlorous acids will be having formula of HClO2. HClO2. You can see that H we have an oxygen which has been linked between the hydrogen and chlorine, and the chlorine will be bonded to oxygen by a double bond. Whereas in the chloric acid we have HCl3, actually it is HClO3. So you can see that between the oxygen and the chlorine, between the hydrogen and the chlorine, we have a single bonded oxygen atom, but the chlorine will be bonded to other 2 oxygen atom. Okay. Next, explain the principles are involved in manufacturing of ammonia by Haber's process. Okay. Here also you must know that how the steps are followed and how to write with a diagram. Okay. So first I will explain with the theory, then I will go with the diagram. The compressed mixture of nitrogen and hydrogen are in the ratio of 1:3 is taken at a pressure of 200 atm, is passed over the catalyst around 700 Kelvin. The catalyst is iron oxide is mixed with potassium oxide and aluminum oxide as a promoter, and ammonia is formed. The gas mixture is cooled and get collected as ammonia. Unreacted mixtures, the gas will be recycled back, and the reactions are nitrogen and hydrogen combined to form what? Ammonia. You can see that reaction here. We have taken the nitrogen and hydrogen as a reaction mixtures in 1:3 ratio, and it is allowed to pass through the compressor. So in the compressor, reaction mixture is compressed and it is passed through the catalytic chamber. In catalytic chamber, your nitrogen and hydrogen in presence of a catalyst known as an iron will be combined to form a ammonia. Ammonia, and also we have added promoters to increase the mixing of nitrogen with the hydrogen. So once this ammonia which is formed, which has been collected in a separate chamber, unreacted nitrogen and hydrogen which is there in the reaction mixture will be moved out in the form of gas, and it is pumped back to sometime to the compressor chamber or sometime directly to the catalytic chamber for the further reaction to happen. This is how we can easily prepare the ammonia by Haber's process by following with these steps, and it is very simple to prepare by this method. Okay, so in the exam if they ask you to write with the diagram, you have to write this diagram along with the explanation along with this balanced chemical equation. Next we have, in the manufacturing of sulfuric acid by contact process, write the reaction and optimum conditions. So here also there are 3 to 4 steps will be there. Let us understand what are the optimum condition and the reactions which has happened in the preparation of sulfuric acid by contact process. So the first step is burning of sulfur with the air to form a sulfur dioxide. So we will take the sulfur which is allowed to react with an oxygen to form a sulfur dioxide. The sulfur dioxide which is further oxidized in presence of vanadium pentoxide as a catalyst and a pressure around 2 bar and the temperature around 720 Kelvin, sulfur dioxide is converted into sulfur trioxide. So the minimum conditions which we have to maintain for this reaction to happen are temperatures around 720 Kelvin, pressure is around 2 bar and the catalyst around, it's nothing but vanadium pentoxide. Okay, it's a vanadium pentoxide. So in the next step, we do the adsorption of sulfur trioxide in the sulfuric acid to give a oleum. So in the third step, what we will do, we will collect the sulfur trioxide and we add some of the concentrated H2SO4. Why we will add a freshly prepared H2SO4 here? In order to remove the excess of water content which has been there in the sulfur trioxide. So it forms what? Oleum. Oleum is the purest form of sulfuric acid. Okay. So if you want a concentrated sulfuric acid, we will take that oleum and we will dissolve it in a water to get sulfuric acid. To get what? Sulfuric acid. And most of you doesn't know that what is oleum and what is sulfuric acid. Both are one and the same. So oleum is the purest form and sulfuric acid is a concentrated one. One more important thing is in the P block, not only we are going to expect the direct questions like with the manufacturing process, we can also expect the question in the form of fill in the blanks. Okay, or you have to predict the product with the reactions which has been happened with the group 17, group 18 or with the group 16 also. Usually group 17 and 18 are repeatedly asked. Go through with all the different kinds of reaction and remember, whenever you study the P block correctly, it is easy for your CET also. Okay. We have taken a reaction where chlorine and the fluorine, they are nothing but interhalogen compound. How does the interhalogen compounds are formed? By the combination of same halogen. Okay, when the halogens are mixed, two different halogens are mixed, it forms what? Interhalogen compound. So here we have taken the equimolar quantity of chlorine and fluorine at a temperature of 473 Kelvin. It forms what? ClF. So we have to see that whether the reaction is balanced or not. Next. So if you take the chlorine in excess quantity, then we mix with the fluorine, we get ClF3. Then if you take equimolar quantity of iodine and chlorine, we get Cli, or you can write 2iCl3, iodochlorine. Next, complete the reaction. ZeF6 plus 3 water. These are all the compounds of xenon. Okay, xenon hexafluoride we have taken. If it is mixed with the water, so already they have given that 6 hydrogen fluorides are formed. See, already 6 hydrogen is left, fluorine is also left. Okay, what is remaining now? ZeO. That's all. And you can predict the product very easily. See that the next one, Fe2 hydrogen is left. And we have 2 fluorine is left and we have a 4 fluorine. Now I'll write ZeO F4. Clear? Next, 4H, H is over and 4F they have given. Remaining 2 is there. So I'll write ZeO2 F2. Clear? It's very simple. Just look at the reaction and you can easily find out the end product. So that's all about the P block elements with the important question. Hope you all understood that how tricky it is to solve with the P block elements. So you can easily get 12 marks from this unit. Hope you all understood with the session. I'll come back with the next unit. Till that, take care and be safe. Thank you.